All right, this is the third video on partial fractions. On the last video, we talked about two conditions for partial fractions decomposition to work. One is that the denominator needs to be factorable, which it is here. The other is that the degree of the numerator needs to be strictly less than the degree of the denominator. That's not the case here. So when that happens, typically what we do is we do long division where we divide the denominator into the numerator. So I'm going to do that in red, and we're going to do that down here and take x squared minus 5x into the entire numerator, 2x cubed minus 13x squared plus 18x plus 5. To do that, we think, what do you multiply x squared by to get 2x cubed? That's 2x, and we line up the powers of x. You multiply 2x times each of the things on the outside of the division sign, so we get 2x cubed minus 10x squared, and now we subtract. So we get 0 minus 3x squared, because negative 13 minus negative 10 is negative 3, and we bring down the rest of the terms. Now we divide negative 3x squared divided by x squared. That's negative 3. We multiply negative 3 times the terms on the outside. That gets us negative 3x squared plus 15x, and we subtract. That gets us 0, and then 3x plus 5. Now that the degree of what's left is smaller than the degree of the divisor, we're done. So 3x plus 5 is the remainder. What that means is that the original problem can now be rewritten as the integral of 2x minus 3 plus the remainder, 3x minus 5, over the denominator x squared minus 5x dx. So the long division gets us that first step. Now we divide this into three separate integrals. We've got 2 integral x dx minus the integral of 3 dx plus the integral of 3x minus 5 over x squared minus 5x dx. The first two integrals are straightforward. The third integral is partial fractions. So we do the partial fractions decomposition by factoring the denominator. So we take 3x minus 5 over x times x minus 5. We can split that into a over x plus b over x minus 5, and now multiply by the common denominator. So we get 3x minus 5 equals a times x minus 5 plus bx. The a distributes, and now we combine like terms. A plus b then has to equal 3, and negative 5a equals negative 5. That gets us that a is 1, and plugging into the first equation, 1 plus b is 3, so b is 2. That takes us back to these integrals. The first integral is 1/2 x squared and has nothing to do with the decomposition. The second one is 3x. The third one, based on the partial fractions decomposition in blue, can be rewritten as 1 over x plus 2 over x minus 5. We can split that up into two integrals and pull the 2 out of the second integral. That gets us x squared minus 3x plus log of absolute value of x plus 2 log absolute value of x minus 5 plus c. So the only new part of this example is the long division part. That's something from pre-calculus courses that you do in algebra. So if the degree of the numerator is larger, or if the degree of the numerator is the same as the degree of the denominator, we can start with long division, split it up like this, and then what's left might end up being partial fractions or might end up being something that we can do in a different way. But you'll see some examples of that on the second partial fractions worksheet. Okay, we have one more video on partial fractions that where we'll be talking about irreducible quadratics, but that's it for this video. Thanks for watching.